Okay, we have the function f of x equals x times x plus 1, and our question is this function increasing or decreasing at x equals 1? Okay, now, people didn't really know what to do with this question, okay? So we need to talk about this a little bit. One suggestion was, well, you just plug in 1. Well, if you plug in 1, you get square root of 2. So I posed the question, well, what does that tell us about the graph of this function? Now, if you were in class, you understand what we did, but you need to think this through anyhow. If you weren't in class, you need to think through the answer to that question. Okay, well, what this tells us about the graph is that the point 1 square root of 2 lies on the graph. Now, if you didn't know that in class, you need to think about your understanding of what the graph of a function is. And hopefully you understand pretty clearly now that the point 1 square root of 2, where x is 1 and f of x is your y value, square root of 2, does give us a point on the graph, okay? But, okay, that's important to understand. You really have to understand that to understand what's wrong with trying to use that to find the slope. That's not a slope, that's just a single point, and you can't tell anything about the slope from a single point. Now there is something you can do to find out what the slope is, but you got to understand what that slope means and how it's related to the formula for the function. So, what do we mean first place by increasing? Okay, a function is increasing. Well, this function, is this increasing? Well, yeah, and people said, yeah, that's increasing. I said, why? I said, well, because the slope's positive. Well, more specifically, and that was a good answer, but more specifically, the slope at every point, the slope of the tangent line at every point is positive. Okay, so it's increasing because it's rising. That was another answer I got, and it's not a bad answer. That's always rising. Okay, it's got a positive slope at each point, and even more specifically, and I'm going to write that in here, it's got the tangent line has a positive slope at every point. So I've sketched tangent lines to this curve at a number of points, and I've made the statement that the function is increasing because the slope of the tangent line is positive at every point. And that gets pretty close to the test that we want to use to determine whether the function is increasing or decreasing at a given point. Now, what is the slope of the tangent line? Well, the slope of a tangent line is a limiting value of the slope of a bunch of segments. And we've been over that, so I'm not going to clutter the picture, but we've been over that a couple of times. And you should understand then that if f of x plus delta x minus f of x over delta x is always positive for small enough delta x, now what's that mean? That means you can always find some distance about basically about the point on the graph, at least some horizontal distance within which the slope is between any 2 points is always positive. Okay, and that's actually going to be true for any 2 points on this graph. But okay, it's increasing if this, and what is this? This represents the rise divided by the run between the point x and the point x plus delta x. Again, we've been over that in a lot of detail. Okay, if that's always positive as long as delta x is small enough, then it's increasing. Okay, so since f prime of x is the limit of this as x approaches 0, it follows that the function is going to be increasing if the derivative is positive. So there's our test. F prime of x has to be positive. Now, another way, just to be sure that we understand what we mean by increasing and decreasing, another way to test for increasing and decreasing, let's just take our f of x equals x squared function. And we look at the point 2, 4, the x equals 2 point. Okay, that point would be 2, 4. Okay, so f of 2 equals 4 tells us that the point 2, 4 lies on the graph. We've got to digest that and make sure we understand what that statement says about the graph, that this point lies on the graph. Okay, now I ask, is f of x increasing or decreasing at x equals 2? One way to answer that question that doesn't involve the derivative, that is a little more intuitive, a little more direct, and this way sort of works. I say one way that sort of works is, okay, let's evaluate f at 1.99, which is just a little bit to the left of x equals 2, and at 2.01, which is a little to the right of x equals 2. We find that f of 1.99 is 3.96, f of 2.01 is 4.04. So as we go from x equals 1.99, just a little to the left of x equals 2, to x equals 2, to x equals 2.01, our value of y goes from 3.96 to 4 to 4.04, meaning that each of these points, if we go in order, 1.99 to 2 to 2.01, each number is bigger than the last. Each y value is bigger than the last. So we're going from left to right, and our y values are increasing. That tells us with pretty good certainty that this function is increasing when x equals 2. So what are we going to do about f of x equals x times the square root of x plus 1? One thing we could do, and we're not going to do that, but you could, use a number just a little smaller than 1, x equals 1, use an x number a little bigger than x equals 1, and see what your numbers are. See if they increase. See if the number to the left gives you a lesser or a greater y value than the number to the right of 1. Then we know whether the function's increasing, decreasing, or level. Or at least we have a pretty good indication. It doesn't prove anything, but it's a very good start, and it shows you what's going on. Well, now, we could do that. In other words, we could do the same sort of thing we did here, or we could take the derivative of the function and evaluate that derivative at x equals 1, because the slope is the value of f prime when x equals 1.